What are Python sets good for? Like lists, sets are collections of values. But unlike lists, sets can't contain duplicate values, and sets are also unordered, meaning the values within a set may move around as new items are added to the set. So what are sets good for? Have you ever found yourself making a dictionary where the values are all the same as the keys? Or maybe you've made a dictionary where the values are all something unimportant, like none. In both of these cases, a set might have been a better choice. Just like the keys at a dictionary, sets deduplicate their items, though unlike a dictionary, sets aren't ordered. So anytime you want to deduplicate data and order doesn't matter, a set might be the best data type to use. Sets are also useful when you need to quickly check whether specific values are contained in your collection. This code reads 10,000 random integers into a list. This code loops over this list and checks whether each of the neighboring integers is also in the list. On my machine, this code takes a while to run, takes multiple seconds. It's slow because checking whether something is in a list takes time, and we're using the not in operator to check a number for containment in our list thousands of times. If we create a set out of our list, and we do the same containment check on the set, our code is much faster. Sets take up a bit more memory than lists, and they aren't ordered the same way that lists are. But unlike lists, sets are always fast at adding items, removing items, and checking whether an item is contained within a set. Python sets also support set arithmetic, using the bitwise operators as well as the minus operator. We can union two sets together using a pipe. We can also intersect two sets using an ampersand. And we can find all the items that are in one set but not the other by using a minus sign. Or we can find all the items that are in either set but not in both by using a caret. Whenever I find myself wanting to compare the values in two different collections, I consider whether set arithmetic might make sense. What if you do want quick containment checks, or set arithmetic, but you also want to maintain the order of the items you're working with? Well, you could take a non-set structure, like a list, and convert it to a set, just for those operations. This program doesn't use a set right now. It has a list of words, and as we loop over this list of words, we're taking the reverse of each word and checking whether it's in the same list. It takes a while to run, takes multiple seconds to run, because checking whether a word is in this list requires us to loop over the list, and we're doing that for every word in the list. If we were to add an extra set to this program, this word set here, and we used that for this containment check, this program would be much faster. We can't even see how fast it is to run because it's less than a second. Even though it does take time to create a new set, that extra creation time is overshadowed by the speed up that this code gets from those quick set containment checks. The simplest use of a set is probably also its most common use, checking for duplicates. If we convert a list to a set, and then we compare the length of the set to the length of the list, we'll be able to tell whether there were any duplicates in the list. That one line of code is definitely my most common use of a set in Python. You can use Python sets for removing duplicates, as long as you don't care about maintaining the order of your items. Sets are also great when you need fast containment checks, and if you find yourself wanting to ask about the common or unique values between two collections, you can use set arithmetic, but the most common use of sets is to ask whether all items in a list are unique.